Welcome to the Explainer. You know, if you've ever marveled at just how polite, helpful, and conversational a modern AI chatbot is, you've actually witnessed a massive leap in technology. But underneath that super slick interface lies a raw, unpredictable intelligence that literally had to be tamed. Today, we're unpacking exactly how we transform that raw AI into the helpful assistant you know and love, using a process that essentially gives it a human touch.
Which brings us to the ultimate question at the heart of the AI alignment problem. How do we teach a supercomputer, a machine that basically just processes vast amounts of data, to actually act human? See, an untrained language model doesn't inherently know what's helpful, truthful, or safe. Left entirely to its own devices, it's essentially an unpredictable monster. It's capable of generating toxic content, spreading misinformation, or just completely misunderstanding what you actually want it to do. The stakes here are incredibly high, because as these models get integrated into our daily lives, they absolutely must align with our human values.
Okay, let's dive into this. Back in 2017, researchers at OpenAI realized something really profound. For decades, computer science relied on humans writing complex, explicit rules, code that explicitly defines a goal function for a machine. But human values are way too nuanced to be hard-coded like that. This quote highlights their realization. Inferring what humans want by simply having them compare different AI behaviors is vastly safer and honestly far more effective than trying to write complex, rigid rules from scratch.
And that exact realization birthed the technique we're exploring today, reinforcement learning from human feedback, or RLHF for short. Think of RLHF as the crucial bridge between cold machine logic and human intuition. It's a machine learning technique that literally bakes human preferences directly into the AI's reward system. You know, in the AI community, there's actually a popular meme that compares a raw AI model to this terrifying, many-eyed tentacle monster called a shoggoth. Well, RLHF is basically the process of slapping a polite, friendly smiley face right onto that monster.
Here's our agenda for today. The alignment problem. Phase 1, the raw model. Phase 2, supervised fine-tuning. Phase 3, the reward system. And finally, results and limitations. The AI alignment problem. Why raw language models need to be tamed. Phase 1, the raw model, creating the monster.
Let's move to and see how this builds across the three major steps of AI training. First, we've got pre-training, which is creating that raw, untamed monster we just talked about. Second, there's supervised fine-tuning, which is kind of like sending the AI to elementary school so it learns basic formatting. And third, we have RLHF, which is like teaching the AI manners, ethics, and social graces.
During that first step, pre-training, the model consumes just a staggering scale of data. We are talking trillions of tokens. To put that into perspective, 1 trillion tokens is roughly equivalent to 15 million books. When an AI is initially trained, it reads indiscriminately from the internet. It absorbs all the wonderful things, sure, but also the clickbait, the toxicity, and all that unfiltered garbage. Its only job during this phase is to simply predict the next word in a sequence. So it becomes incredibly powerful and knowledgeable, but it is totally unaligned with human needs. I mean, if it reads a toxic forum post, its instinct is simply to predict the next toxic word.
Phase 2, supervised fine-tuning, sending the AI to school. And this brilliantly illustrates why this second phase is absolutely necessary. Just look at the difference here. If you ask a raw Phase 1 model how to make pizza, it might just treat it as a sentence to be completed and output for a family of 6. It doesn't know you want a recipe. It's literally just playing autocomplete. But after supervised fine-tuning, the model actually recognizes the intent. It outputs a helpful list of ingredients. It learns to stop predicting random internet text and start acting like an actual assistant.
So how does it actually learn this? Through a process called behavior cloning. OpenAI, for example, hired highly educated human labelers, many of them with master's degrees, to manually write out perfect responses to tens of thousands of prompts. They created around 13,000 high-quality pairs just for InstructGPT. They physically demonstrated to the AI how it should behave, and the AI simply cloned that behavior. But there's a huge catch here. Having humans manually write out perfect paragraph-long answers for every single possible question is incredibly expensive, it's painfully slow, and it's totally unscalable. It creates a massive bottleneck.
Phase 3, the reward system, teaching manners via RLHF.
Now, what's really interesting about this pipeline is how it solves that bottleneck. We've already done Step 1, the supervised fine-tuning. In Step 2, Instead of asking humans to write the answers from scratch, we simply ask them to score answers the AI has already generated. It is so much faster for a human to act as a critic than as an author, right? This ranking data is then used to train a brand new, totally separate AI called a reward model. Then, in step 3, the main AI practices generating thousands of responses, and the reward model automatically scores them. The main AI uses an algorithm called Proximal Policy Optimization, or PPO, to constantly adjust its behavior to maximize that reward score. It literally learns by trying to get the highest grade possible from the automated judge.
But training that reward model requires actual humans to sit down and compare AI outputs. And this brings up a really fascinating problem. Human values are incredibly subjective. Take a real example from an Anthropic dataset. The prompt is, "How can I get my dog high?" The winning response chosen by the labeler is a simple deflection. "I'm not sure what you mean by that." But the losing response is this preachy lecture about dogs needing to experience the world in a sober state of mind. You might actually find the losing response funnier or even more appropriate. Ranking these responses requires some really nuanced judgment calls about safety, helpfulness, and tone.
And because of that subjectivity, human preferences are incredibly diverse. Data shows that the agreement rate between human labelers is only about 73%. That means, if you put 10 people in a room and ask them to choose the better of 2 AI responses, almost a third of them will completely disagree with the majority. This makes formalizing a perfect mathematical reward system incredibly challenging. Because, let's be honest, there's rarely a single, universally agreed upon, correct human value for any given prompt.
Results and limitations. Does RLHF actually work?
So the crucial point is, yes, it absolutely does. Data from the InstructGPT paper shows a massive breakthrough. The RLHF-trained model, represented by the red line, absolutely soars above the massive raw GPT-3 model in evaluations. When real human beings evaluated the outputs, they overwhelmingly preferred the answers generated by the AI that had been through the human feedback loop. The RLHF model followed instructions better, it generated less toxic text, and it was just significantly more helpful overall.
But what makes that breakthrough even more astounding is this number: 100. The RLHF model that won all those human evaluations had 1.3 billion parameters. The raw model it defeated, that one had 175 billion parameters. By simply incorporating human feedback, researchers achieved vastly superior performance with a model that was literally 100 times smaller. It proves that when it comes to AI, sheer size and brute force data are not enough. Alignment and human manners punch way, way above their weight class.
But of course, this explainer wouldn't be complete without neutrally addressing the limitations, because RLHF is definitely not a magic bullet. First, these models still suffer from hallucinations. They can confidently make things up, because the reward model might accidentally reward an answer that just sounds convincing, even if it's factually wrong. Second, there's an alignment tax. By optimizing so heavily for polite conversation, the AI actually performs slightly worse on raw, traditional natural language processing benchmarks, like translation or reading comprehension. And finally, as we discussed, the subjectivity of the human labelers means the AI is heavily biased toward the values of the specific contractors who happen to rate its data.
Which leaves us with a deep, really provocative question to ponder. As these models scale up and become integrated into our global society, they're continually learning from human feedback. But if AI learns its values from our feedback, whose values are we actually teaching it? Are they the values of the developers, the contractors, the everyday users? RLHF has successfully tamed the raw AI beast and given it a friendly face, for sure. But deciding what kind of mind sits behind that face? Well, that's a conversation we're all just beginning to have. Thank you for joining me on this explainer, and I'll see you next time as we continue to unpack the cutting edge of our world.